Now let's go to a slightly complicated situation where we have 3 circles. That is, I have added one more game, basketball. So let's start off with the same. Let's assume the total number of students in the school is n. The number of students who play football, who play cricket, who play basketball. Earlier we had only 2 circles. So we had x, y and z, right? There were only had 3 variables. Here we'll have actually 7 variables. Let's assume this to be x, y and z. And let me call this A, B and C, and let me call this to be P, right? So that's altogether I have 7 variables. So what is this blue circle? Let me define this as people who play football. This is people who play cricket, and let me take the green circle as people who play basketball, right? So let's fill this other thing, right? Number of students who play only football. I'm talking only football. I know this entire blue circle is people who play football, but I see X, A, P and C. This is all the number of students who play football, but I need to figure out the people who play only football. That is this, because it's not overlapping with other. So this A, this A is this part, right? That is, this part is overlap of this and this, football and cricket, right? C is overlap of blue and green circle and no, not the red circle. So that's why it's basketball and football. And B is overlap of cricket and basketball only, and P is overlap of all 3 circles. That's basically people who play all the 3 sports. So number of students who play only football is X. The number of students who play only cricket is Y. The number of students who play only basketball is Z. The number of students who play both cricket and football, right? So this one is a bit tricky. Based on the statement, the answer should be actually who play both cricket and football. Cricket and football is this. That's basically A plus B actually. But I'll come to this. I'll just change this to this. Number of students who play only cricket and football, right? That is, they play both the games, but only these 2 games, right? I'm talking about the number of students who play both cricket and football only, right? Both cricket and football only. They don't play basketball. If I just say the number of students who play cricket and football, it could also include people who play cricket, football and basketball as well. So be careful with that. That's why you have to have that explicit statement says who play only 2 games. The number of students who play only 2 games and they play cricket and football, that would be simply A. That would be this part. Both football and cricket, but not basketball. This one is basically the number of people who play 2 sports or more. So cricket and football is played by A, and also these people, they play cricket, football and they also play basketball. These people play cricket, football, but they don't play basketball. So, but you still need to count them if I go with that. Just make the same changes, only this, right? The number of students who play both cricket and basketball only. So cricket and basketball only would be this part. So that's B. Basketball and football only. Basketball and football only is C. And the number of students who play all the 3 sports is P. Right? Once I've got these 7 variables, right? Like how we had 3 variables here in Venn diagrams with 2 circles. Here we have 7 variables. So how many students play football? That is football only, football and cricket only, football and basketball only, football, cricket and basketball, all 3 games. So that will turn out to be X plus A plus P plus C. The number of students who play cricket would be only cricket, cricket and football only, cricket and basketball only, and all the 3 sports. And this would be Z plus C plus B plus P. That's the number of people who play basketball. That's how you will figure out the answers. And once you can connect all these statements properly with variables you assume, right, they'll give you some of these clues. You can just say the number of students who play football is 50. I substitute here and solve and find these variables and answer the given question. Here it's a group of 100 kids, 30% like blue color, 50% like yellow color and 45% like green color. So it's talking about 3 variables like blue, yellow and green. So I have a Venn diagram with 3 circles. And this is what I'll end up with. Let's say this is blue color, this is yellow and this is green color, right? So let me take, as I said, I take X, Y, Z, A, B, C and the common is P. So 30% like blue color. That is people who like only blue, people who like blue and yellow, people who like blue and green, and people who like all three colors. So X plus A plus B plus P is 30%. Right? People who like blue color. People who like yellow color would turn out to be Y plus B plus C plus P. Same, right? Only yellow is Y. Yellow and blue is B. Yellow and green is C. All three colors is P. That is 50%. People who like green color is 45%. That is only green is Z number of people. People who like green and blue is A. And then C is for green and yellow and P is for all three. So A plus C plus P is equals to 45%. Right. Then it is also known that 15% of the kids like both blue and yellow. Right. So that's basically saying 15% of the kids both blue and yellow is 15% of the kids, right? So 15% yellow, both blue and yellow. So let me take both blue and yellow is this part. So again, as I said, should I also count P? Ideally, you should, based on the way the sentence is. It is also known that 15% of the kids like both blue and yellow. So these kids like both blue and yellow. These kids also like both blue and yellow, but they also like green. So it should have been people who like both blue and yellow only, right? Both green and blue only, and 18% like both yellow and green only. They have to be explicitly mentioning this. Okay, let's solve this assuming this only is what they have given. Both blue and yellow only, that is B is 15%. Only green and blue, that's basically, that's green and blue is this part, that's 18%. Only yellow and green would be, yellow and green is this part, that is C is 8%. And then 8% like all three colors, that's basically P, right? So P is given as 8%. This is 18, sorry, this is 22%, and this is 18%. B is people who like both blue and yellow. Blue and yellow is liked by 15%. 22% like both green and blue. Green and blue is A, that is 22, and C is 18% who like both yellow and green, and 8% like all three colors. So they gave us B, A, C, P. So I can substitute here A, C, P, B, C, P, A, B, P to get X, Y, and Z. I know all the values that are, as I said, 7 equations, 7 variables. That's good enough for me to answer it. Anyway, the simple equation is straightforward, give the equations. Let's assume if the question did not have these only words, okay? What would that lead to? Then as I said, I should count that blue, right, and yellow is liked by people who like both blue and yellow only, and P is the number of people who like all three colors. That would be 15%. A plus P is 22%, and C plus P is 18%, and P alone is 18. So 8, right? 8% is like all three colors. So if I know P is 8, then automatically implies C is 10. This implies A is 14, and this implies B is 7. You know, I can also do this and do it. So as I said, the answers would come different, but you can calculate. There's nothing different in terms of complexity in solving. It's just about how the answers would vary. So let me do with this. Right? A is 22%. B is 15%. That actually is giving me a wrong answer. Why? Because you see this. X plus A is 22 plus B is 15 plus C is 18. Sorry, P is 8. So this is like is equals to 30% is what the statement 1 is, the equation 1 is. But this alone is more than 30, right? This will come to be 45, which will give me X as minus 15%, which sounds like a wrong one. So I guess let's actually, do it without the only word, that is this approach. A is 14, B is 7, C is 10, and P is 8. So what would this turn out to be? X plus A is 14 plus B is 7 and P is 8 is equals to 30%. So that will give me X as 14 plus 7, 21 plus 8, 29. So 30 minus 29 is 1%. Right, that is still giving me positive value. That's acceptable. Now let's come to second equation. Y plus B is 7, C is 10 and P is 8 is equals to 50%. 17 plus 8, 25. So 50 minus 25 is 25%. That Y is 25%. Similarly for Z, it will be Z plus A is 14, C is 10 and P is 8 is equals to 45. So 24, 32 So Z plus 32 is 45 and Z is 13%. Right? So basically this is wrong because we are getting a negative value. So this is how it should have been. So that's why I think the question is correct. So it does not include only words. Right? So it is also known that 50% of the kids like both blue and yellow. What you have to understand is both blue and yellow is not just this thing, also this thing. Right? That's why you have to write B plus P. Why? What is B? The kids who love yellow and blue only. That means they only like these two, they don't like the green. This is the kids who like yellow and blue and pink also. But the clue is saying that 15% of the kids like both blue and yellow, which is acceptable for this and this category. So we need to add 2 colors plus 3 colors, 2 plus 3, 2 plus 3 for this individually. Once I do it, I know all the 3 colors are liked by 8%. I can individually find only 2, only 2 and only 2 and then substitute it back here to get only one color. So how many kids like only one color? X plus Y plus Z is the answer for this. Right? X is the number of students or kids who love only blue. Y is the number of kids only like yellow, and Z is the number of kids only like green. So I just need to do 1% plus 25 plus 13. Right? This will turn out to be 39%. So that's the answer for this. Right? That's how you'll solve this questions. Right? It's simple once you get hang of this application, like 3 circles have 7 variables x, y, z, a, b, c, p. Just understand the x, y, z are only one color, a, b, c are only 2 colors, are liked, are loved, and p is all 3 colors. Right? That is how you should have the 7 variables. And accordingly write the clues proper way and get the answer.